Okay, sorry I didn't fix this. This is the Unit 5 review, and it is 2017. All right, find the solutions given a 0 or a factor. Okay, it tells you right here that x is 3. So remember, when we get down to the end, we can even write it right now. This is the first of our answers. Don't forget that one. I've seen a lot of people over the last few days getting down and only writing 2 answers and not 3. So please make sure you don't forget to bring this down to your final answer. So back to what the problem is, synthetic division. We're told 3, so we just put 3 there. We look at our original, we have a cubic term, we have a quadratic term, we have our linear term, and we have our constant term. No need for 0 fillers. We drop down, multiply, add, multiply, add, something didn't work right. What did I do wrong? 3 times 6 is 18. There's my error. I was looking at the 3. Okay, happens. There's my answer. Negative 16. Now when I multiply, I get negative 48, and that works out. Could not see the error right in front of my face. So, we make this x squared plus 6x minus 16 equals 0. We factor x, 8 times 2 is 16. We want more positives, fewer negatives. Set them both equal to 0. And here's the part where you see a lot of people saying, oh, my answer is 2 and negative 8. And leaving off the 3. So don't forget to have all 3. Negative 8, 2, and 3. And remember, if nothing else, there's nothing stopping you on a quiz from putting this in the graphing calculator. X to the 3rd power plus 3x squared minus 34x plus 48. There is no reason you cannot look on here and confirm the zeros. There's 3, there's 2, and there's negative 8. You've got the tool there, why not use it? Nothing else to check your answer. Now, on to number 2. This time it tells us x plus 3. We set that equal to 0, and we get negative 3. That's the number that goes in the box. So we have quartic, we have our cubic, we have our quadratic, we have our linear, and we have our constant. No need for zeros again. Drop down to 1, negative 3. 8 plus negative 3 is 5. Times negative 3, negative 15. Negative 4. Positive 12. Negative 20. Positive 60 and 0. That gives me x to the 3rd plus 5x squared minus 4x minus 20 equals 0. I'm going to factor by grouping. I can take out an x squared and get x plus 5. I know I want an x plus 5 over here. So what do I divide the second parentheses by? Negative 4. That gives me x squared minus 4 times x plus 5 equals 0. Now at this point, there's 2 ways to do the x squared minus 4. Some of you might have noticed that it's a difference of 2 squares and done x plus 2, x minus 2. Or some people just did move the 4 over and do x squared equals 4. Now the problem with the second way is Many people just put 2 as an answer. And as you can see from this, it's 2 and negative 2. You have to remember when you're solving with square root, when you say x equals plus or minus 2. Can't forget that. So whichever way you do it, just make sure you pay attention. So there's 2 of my answers. Here's my next one. X equals negative 5. And don't forget my last one. We need to have 4 answers. So x is negative 5 plus or minus 2 and negative 3. There are my 4 zeros, my 4 solutions, my 4 roots. Okay, on this one, so a lot of people want to go all the way on this problem. All you need to do is identify the possible. So there's my Q, there's my P. P over Q, negative 4, factors of negative 4 over the factors of 1. If it's just the factors of 1, plus or minus 1, plus or minus 2, plus or minus 4, I am finished. But here at number 5, it's 1 times 5. So I have to put all of my factors of 24 over 1 and 5. So this is 5 few more. Plus or minus 1, 2, 3, 4, plus or minus 6, 8, 12, and finally 24. Now I have to go back and do all of those again over 5. These are all my possible answers. Well, that's 5. So there you go. Quite a few of them. 2, 4, 6, 8, 10, 12, 14, 16, doubled, 32 possible zeros. A lot of choices. Now, use synthetic division. Now we got to put it all together. I know I have a cubic term and a quadratic, and here's my linear, 1, right? And my constant. But what number goes in the box? That's where I use my P's and Q's. It's going to be P over Q, factors of 6 over 1. So, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now I can do trial and error, or I can use my calculator to make life a little bit easier. So I put in x cubed minus 4x squared plus x plus 6. And I'm going to look at the table and find one of my zeros under y. There's 1, negative 1. There's 2 and 3. There's actually all 3 of them. But I cannot just cheat and write down negative 1, 2, and 3 because the problem says use synthetic division. But I can use this to have a number to start with. So I can start with any number up here. Negative 1, 2, or 3. Pick one. I'm going to go with 2. Multiply, add. Multiply, add. Multiply, add. Now, I have x squared minus 2x minus 3 equals 0. Which factors to x minus 3, x plus 1. So my solutions are x equals 3 and negative 1. And that's where people tend to stop. Don't forget to bring this over. And 2. Okay? Now, just to show you, you can fast forward this part if you want. But let's say I would have chosen instead 3. It would have still worked out. Drop down, multiply, add, multiply, mess up here. Negative 3. There you go. Negative 2, negative 6, 0. Now, x squared minus x minus 2 equals 0. X minus 2, x plus 1. Okay? There's my answers. 2, negative 1, and 3. So, any one of those numbers I would have started with, I would have ended up finding the other two. And I have the calculator to back me up. Okay, now use any method you want. Okay? I see 4 terms. I'm going to start off by trying to just factor it by grouping. So I'm going to take out 4x squared and divide. X plus 1. I wanted x plus 1 over here. So I divide this by negative 1. That gives me 4x squared minus 1 times x plus 1 equal to 0. Well, this one's easy. That's going to be negative 1. There's one of my answers. I'm looking for 3. So 4x squared minus 1 equals 0. Divide by 4. X squared equals 1/4. I'm going to rewrite. That's sloppy even for me. Take the square root of both sides. And I get x equals plus or minus 1/2. Why is that? Because it's the square root of 1 over square root of 4. Square root of 1 is 1, square root of 4 is 2. So my 3 answers are x equals plus or minus 1/2 and negative 1. I can put that in the graphing calculator. The only one I'm going to see in the table is negative 1, unless I change my settings to include halves. And then all 3 would be there. Okay, this one, I need to move the 40 over first. Now, some of you could have done synthetic division, found your P's and Q's for 40. And I'll tell you right now, to check yourself by putting that in the graphing calculator. And if you put that in the graphing calculator and look at the table, you're not going to find any zeros. You could also do the quadratic formula, except for the fact of this being a 4. So that won't work. But I saw some people trying the quadratic formula. Remember, it's a quadratic formula, which means you can't do it if your exponent is a 4. So that won't work. So that leads us back to good old-fashioned factoring. Okay? Now, let's step back and think if this was x squared minus 6x minus 40. I would just factor it, x minus 10 and x plus 4. Hard to read, but you see what I'm doing. Right? It's the same thing. Except now, instead of being x times x, it's going to be x squared times x squared. This is still negative 10 plus 4 equals 0. So x squared equals positive 10, and x squared equals negative 4. Set them both equal to 0, move over the numbers. Take the square root of both sides. X equals plus or minus square root of 10. There's 2 of your answers. Take square root of both sides. Well, plus or minus always. Square root of 4 is 2. And you get the negative out, we have I. And there are your 4 answers. 2 real and 2 non-real. Moving on. Okay. Zeros of 0, 3, and 4. Well, if you go back here and think about how we knew that x plus 3 was negative 3, we use that same knowledge. For 3, we're going to have x minus 3. Because if you set that equal to 0, you get a solution of 3. For positive 4, x minus 4. And for x of 0, all you need is quite simply an x. Now, I've seen a lot of people putting x plus 0 and x minus 0. You just need to put an x. Now, you have choices here. You could send the x in and then FOIL, or you can FOIL and send the x in. I'm going to FOIL first and get x squared minus 4x minus 3x plus 12. Now, you can send the x in now or simplify. I'm going to simplify first. X squared minus 7x plus 12. Now I send the x in, I get x cubed minus 7x squared plus 12x. And now it is in standard form. On to number 9. Oh, and lead coefficient of 1, you're going to have that because, see, I ended up with that. Right there. On number 9, I still want a lead coefficient of 1. My zeros are going to be at 4, so x minus 4, negative 5, so x plus 5, and negative 2, x plus 2. I'm going to start by FOILing the first two. It doesn't matter. You can do any two of these. X squared minus 4x plus 5x minus 20 times x plus 2. I'm going to join my middle term. X squared plus x minus 20 times x plus 2. Now I just send the x in. X cubed plus x squared minus 20x. Now I send the 2 in. Plus 2x squared plus 2x minus 40. There's nobody for the x cubed. X squared plus 2x squared is plus 3x squared. Negative 20x plus 2x is negative 18x. And the minus 40 is just minus 40. Standard form. Notice I have a lead coefficient of positive 1.
All right, you're going to notice these are a little bit different than what you just saw in the preview because we updated and changed these graphs to make them a little bit easier for you. So, number 10. If you look at the degree, you look at all these x's, well, that's supposed to be a little bit higher. That's supposed to be x to the 1, x to the 1, x to the 1. Sorry, it's a little bit off. So if you multiplied all these, you distribute them all out, you would get x cubed. So you would get a cubic. All right? Now lead coefficient, 1 times 1 times 1. That's it. Your end behavior. Being that it's a cubic, and we're going to graph this here in a little bit, but remember, if it's a positive cubic, it's going to generally look like this. And if it's a negative cubic, it's going to go the other direction. Like so. All right? So, with a positive cubic, we'll come back to this when we look at the graph, we're going to analyze the end behavior. Okay, solutions. You look at this right here, all the binomials. So x minus 2 is going to lead to 2. X plus 2 is going to lead to negative 2. And x minus 1 when you set it equals 0 gives you 1. Now the multiplicity of each of these is, again, the exponent up here. Sorry, word's a little bit off. On each of the binomials. All right? So each binomial has an exponent of 1, so the multiplicity is 1. The domain, and we'll come back to that again after we do the graph. So we go to our graph, or our calculator, my bad, and we're going to clear it out, and we're just going to put this in. So parentheses, x minus 2, parentheses, x plus 2, and parentheses, x minus 1. And we hit graph. And there's our general positive layout. We hit table. Okay. Now I have this going by 0.5s. If you don't want that, you can go to this and call it start at 0 and go up by 1. I just had it going by 0.5 from problem last semester. So here we go. We are only going to use from -2 to +3, because those are the only points we can graph. All right? -2, 0, -1, 6, and so forth. So I know from my x-intercepts from before, we have 2, 1, that's a horrible dot, and -2. And then we also had -1, 6, sorry, this board is way off. We have 0, 4, and 3, 10. So 0, 4, and 3, 10. So it comes up, comes back down, something like that. All right? So let's go back up and analyze this. Our end behavior. As it is going left towards -infinity, it is going down towards -infinity. As it is going right towards positive infinity, it is going up towards positive infinity. The domain is -infinity to positive infinity, and the y-intercept right off of our table is 0, 4. All right, moving on to the next one. Number 11. Okay, so the degree. We have to look at the x's. We have x squared here. This is basically x squared, and this is x to the 1. So that's 2 plus 2 plus 1, so that's a degree of 5. I think I got the board fixed. Now, lead coefficient. This is going to be 1 squared, that's going to be 1, and there's our -3. Now, please remember, though, if there were any numbers inside the binomials in front of the x's, we would have to multiply by those also. So in behavior, we'll get to that here in a little bit. We'll come back to that, domain, intercept. So we're going to put that in the calculator. So clear out what we got. All right, so we have -3x squared, parentheses, x plus 2 squared, and then we have an x plus 3. We hit graph. Okay. Now, notice since it's an odd one again, it's going in opposite directions. So we have one going up and one going down. Remember, evens will always be going in the same direction, like a smiley face or a sad face, or a W or an M. But when you have 3s and 5s and so forth, they're going in opposite directions. Now you can look at this one right now before we even graph it and say, what's the end behavior? Well, as it's going left, it's going up. So as it's going left toward -infinity, it's going up towards positive. And what's the opposite of that? As it's going right, it's going down. All right? Solutions. Well, people forget this one all the time. That is a solution of 0. All right? Then the next binomial we have is -2, and then we have -3. Now the multiplicity. Okay? The multiplicity comes from this exponent. So 2, 2, and 1. The domain, as you saw from the graph, it was going left forever and right forever. And y-intercept, let's go to the table. So you go to the table and try and get some points. Well, there's 1. There's all over here. Now look, this is going to be hard to graph, because look how big those numbers are. The only numbers we have really are our 3 intercepts at -1, -6. That's it. Everything else is off the chart. So we have our 3 zeros at -3, -2, and 0. And then we had -1, -6. Now what's it doing? It's coming down here like this. We don't know exactly where that went. It bounces off here. That's horrible. It bounces off here and goes down. Okay? Apologize for that lack of bounce. Okay? So where's the y-intercept? It's at 0, 0. So here's my multiplicity of 1, because it bounced through. And then these two have a multiplicity of 2, because they're bouncing. And that's it. All right, next one. 3x times x minus 2 squared times x plus 1. If you're comfortable with this, you can fast forward to the actual part of this. So this is very similar to the last one, except this is a minus 2. And this is a plus 1. Otherwise, very similar. So we hit graph. Oh, wait a minute. There was one other difference. This is not 3x squared. Sorry. It's just 3x. Did not get rid of that. Delete. There we go. So you can tell that this is an even number 1 because it's going in the same direction. It's a funky looking W. So we have 3x to the 1. This is squared, and that's 1. So that's 4, which makes it quartic. The lead coefficient is 3 times 1 times 1 times 1, or just 3. The end behavior, as we saw, as we went left, it went up, and as it went right, it went up. It's a happy W instead of an M. Don't forget this for solutions. That is a solution of 0. There is a point right there at 0. This one is positive 2. And this one is negative 1. Now, the 3x has a multiplicity of 1. The x minus 2 has a multiplicity of 2, and the negative 1 has a multiplicity of 1. So when we graph this bad boy, it comes down like so. Little loop here. Something like that. All right? So we have a pass-through, and a bounce. All right. Now in this one, we're going backwards. So we need to find the zeros. Now I apologize, this is supposed to be a 0 here. Okay, this is supposed to be negative 4, it's a little bit off. That's supposed to be a 2. It's just shifted off a little bit. But let's go with that. So let's write down our zeros. Negative 4, 0, and 2. Let's go back to number 12 and think about it. X minus 2 led us to positive 2. Well, we have that answer then. This is x minus 2. And 3x gave us a 0. This one's just x. And kind of thinking the opposite way, this is x plus 4. So we just write that. X times x plus 4 times x minus 2. Now we just have to look for multiplicity. At negative 4, it bounces. So I need a squared there. Pass through, so that's a 1 and that's a 1, and we're done. That's it. All right, now for this one, it says graph using synthetic division. Well, first off, let's just graph it. Let's just go to the calculator and put in x cubed, oh, we made a change on this. X cubed minus 3x minus 2. Sorry about that. So there's a change on that one. So let's put that in the calculator. X to the third power minus 3x. Hopefully you notice right there we skipped the x squared. So we're going to have a 0 somewhere in there. Minus 2. Let's graph it. Okay, simple cubic. Right? We can go to our table and find, let's see how many zeros we find. We find 1, 2, we find 2 of them. Okay? So, we can use either one. It says synthetic division, so we still have to do synthetic division. But we can choose to use -1 or 2. Personal choice. So, let's say we go with the -1. Alright? We look back. There's a 1. We talked about how there was no x squared. There's our -3 in front of the x. And there's our -2. Drop the 1. Multiply by -1. Add. Multiply by -1. Add. Multiply by -1. Add. And we should have no remainder. That should be a 0. If we don't have a 0, we did something wrong. Now, that leads to x squared minus x minus 2 equals 0. And then we have to factor that. But don't forget, we cannot forget this x plus 1 right here. Now, when we factor x squared minus x minus 2, we need 2 sets of parentheses. X times x is x squared. 2 numbers that multiply give me 2. There's only one choice. One's got to be positive, one's got to be negative, because it's a -2. And we want more negatives than positives. Now notice we have 2x plus 1s. This is a fine way to write it. We could also just do this. That's another way of writing it. It doesn't matter. So what does that mean? At -1, we have a dot, and it's going to be a bounce. And at 2, we have a pass-through. So let's go back to our calculator. Let's get some other points, like -2, -4. 0, -2. Always good to have that y-intercept. And 1, -4. That looks good enough. So it comes up through here, bounces off of that, goes down, comes up. Great. Now, here's a big thing. When we're doing this part, do not base it here. Always go back to the original. The graph and all this information is based on the original problem. So, what was the degree? It was 3. It was a cubic. The lead coefficient was just 1. The end behavior, as it goes left, it goes down. As it goes right, it goes up. And the y-intercept we said was 0, -2. Solutions, -1 and +2. And remember, this was a bounce, and this one was a pass-through. Now, local maximum minimums, we don't have to use a calculator for that. That's easy. Here's the maximum at -1, 0. And the minimum was at 1, -4. That was on our table, so we didn't have to do the calculator for that. All right, and last but not least, new problem. Let's put in our calculator. Again, you can fast forward through this part if you want. Notice there's a little negative there, x to the third power. Minus 2x squared. Plus x minus 6. Okay? See what it looks like. Okay, it's a negative cubic. So since it's a cubic, it has a degree of 3 and -1 for the lead coefficient. As you saw from the graph, as we went left, it went up, and as we went right, it went down. So we had a point at -3, and that was it. Okay, for x-intercepts. So let's get some points on here. -2, -8, and -1, -8. That's interesting. So -2 and -1 both here. Which means it is dipping down somewhere below that. What's my y-intercept? 0, -6. And then we have 1, -8. So it comes up here and goes back down. And actually goes a little bit above the -6 there. So, to find the maximum minimums. Okay, let's do the minimum first on the left side. So remember, we go to second, calculate. We want the minimum. So we hit 3. We bring our little buggy thing over here to the left side of the valley. Anywhere. Anywhere here is fine. And we hit the right side. So we go down through the valley, up the right side, be somewhere on the slope here. Hit enter twice. -1.5, -8.6. -1.5, -8.6. For the maximum, we just do it again, trace. We choose maximum. We put the little buggy on the left slope, hit enter, go over the mountain, leave it right there, hit enter twice, and there we go. 0.2 and -5.9. So 0.2, -5.9. That's my local maximum. And that's it.